Okay, in this video I'm going to cover measures of variation. So let's see what are going to be our objectives. What is this? It's not moving. 1 second. Okay, I'll go this way. So we are going to cover range of data set, variance and standard deviation of the population and of a sample. Going to cover. We're going to cover empirical rule, skip Chebyshev, and we're going to drop sample standard deviation for grouped data. Okay, range. Well, range is a very simple definition that everybody knows. So it's a difference between maximum and minimum of data entries. Data must be quantitative to calculate the range. That is going to be the requirement of the range. Obviously, you can't do green minus yellow, right? So it has to be quantitative. So therefore, range is equal max minus minimum. Maximum minus minimum. Okay. So let's find the range. It's very easy example, very simple example. A corporation hired 10 graduates. The starting salaries for each graduate are shown. Find the range of the starting salaries. So if we want to know what's the range of starting salaries, obviously this dollars amount, they are measured in thousands. So the maximum in this case, from what I see, is 39. I mean, minimum 38. And the maximum is going to be 47. Therefore, well, here they arranged, if you have a large amount of numbers, then it makes sense to arrange them in ascending order. So you can see beginning would be the minimum, ending will be your maximum. Okay, so the range of starting salaries, it's going to be $10,000 because 47 minus 37,000 minus 37,000 is going to be $10,000. Very simple. Deviation. Let's understand what deviation is. Deviation, it says difference between data entry X and the mean of the data set. So shortly saying, deviation is an error. How do we identify? If we have a graph, let's say, our data centralized, let's say somewhere here, yes? And the element you are the subject of interest, let's say it's located right on the edge somewhere here. And if you know how much deviation is, which means, that means you want to know how much this element is drifted away from the mean, where main data are centralized, are located. So that's difference between the subject of, between element you are interested in and the average of centralized data is going to be deviation. Okay? So x minus mu. X is this value of x, it's our element. Mu is the mean of the population. Sample data set. So if we are dealing not with population, but we are dealing with sample, then the deviation for the sample is going to be x minus x bar. Remember, mu is average for the population, x bar is the average for the sample. So let's learn how we are finding deviation for every single salaries. And then I'll explain why do we need that deviation, especially in this case. All right. So to find deviation, we need to know the value of your element, which you have here, 41,000, 38,000, 39, and so on, all these 10 elements. And we need to know the average, correct? So average is the one that we need to calculate. Let's see. To find out average, what we are going to do, we are going to add all these numbers, right? All these numbers, we are going to add them up. Here it is. Let me see. Sum of x. So if you add all these numbers, you get 415. And obviously, if you add 3 zeros, it will be 415,000. And we divide by 10 because we have here 10 salaries. Okay? So we get 41.5, which means $41,500. Now, why is it important? How this statistical problem is gonna help you in business or anywhere else? Very easy. We know that the starting salary between $38,000 and $47,000. And we know that average of hiring salary is $41,500. So knowing how much your salary is, then you can compare to average, for example, and you will know if you got pretty good high salary, if that is above average or below average, which will tell you how much the company appreciates you, how much do they need you, obviously, right? If they give you $39,000, that's way below of 41,500. So you would understand that they don't value that much, or they are not interested in you that much, unfortunately. But if they give you about $45,000, that's way above 41 and a half, you will be extremely happy, correct? There we go. This is a type of statistical problem, but that will let you know where you stand at. Since you can't ask around for how much they hired, knowing this data, you can figure out for yourself if your salary is starting salary is good enough or not good. All right. So let's figure out how we're gonna find a deviation. So those are all our salaries with thousands now, and we know the average is 41.5 thousand. So deviation, we said element minus the average, correct? So 41.5, so 41.5 is negative 0.5, 38 minus 41.5 is negative 3.5. So which means in this case the numbers that are different, when difference is negative, that means these salaries are way below of average one, because only then you are getting negative number, right? 39 is less than 41 and a half, 38 is less than 41 and a half, 41 is less than 41 and a half. But when you get, highly positive, let's say 5.5, then you can say that your salary is way above of average salary. See, negative 0.5, it's getting close to your average. 2.5, that's not bad, above the average, and so on. Okay, so this is the example of how to find deviation. So you practically take every single value in the database and subtract the average. Okay. Here is the formula. One thing I have to tell you, don't get scared of this formula, because in announcement I posted online calculator for variance and for population standard deviation. Okay, the calculator will do it for you, will calculate the value, but I'm going to explain how it works just for your knowledge, whoever is interested, and I'm pretty sure there are people that are interested. So let me explain this. So deviation, and first of all, let's understand what means variance. Here is example. Let's say I have a family overseas, and rarely on Christmas I'm trying to send them present, some package. Okay, if I take big box and only few items, so when I shake this box I will see a lot of noise and I would hear how these items are shaking in the box. But if I take small box and pack that box with items, you can shake as much as you want, you won't hear any sound, right? That these items will not shake. So population variance is nothing else but distance between items, distance between elements. Okay, the lesser elements, the further elements from each other, the greater is going to be variance. The closer elements to each other, the less is going to be variance. Now this letter sigma, we call it sigma. Okay, we call it sigma squared. It's a population variance. We measure in square. This is how you write it, sigma squared. See? It's not bad, is it? So that is your sigma, population variance. Okay, and population standard deviation, that's also deviation, how far is error, how far the element is from the mean. We call standardized deviation. So it's always gonna be, no matter what, standard deviation is always gonna be square root of variance. See, here it is, square root of variance, which means square root x minus mu squared over n. Now let me explain what is x sum x minus m squared. X minus n, m, as you know, x minus m, as you know, is deviation, right? So because the deviation can be negative, and we don't use a variance negative because distance cannot be negative, therefore we are squaring and summarizing all these variances from all elements, right? And dividing by n, which is amount of all elements in the population. So, and this same value, once we find out, we are going to take square root, and we will get population standard deviation. So here is how to figure out standard deviation. Those are instructions that you can read one by one, but I'm not going to read in this video. Instead, I'm just going to show you how to work with it. So, the same problem we have, average recall 41,500, and salaries are 41,000, 38,000, 39,000, and so on. So let's find population, variance, and standard deviation of the starting salaries. All right, population, standard deviation. So let me rewrite here the formula. What was that? Sum x minus mu squared over m. That is equal variance, or sigma squared. So let's see how we are going to work with it. So first operation in this formula, first one, we're going to get our deviation, right? X minus mu. Our x is, here we have all lined up, our x's, all right? the average of this mu, we know it's 41,500 or 41 and a half. All right. So let's subtract from every element this average 41 and a half. 38 minus 41 and a half, 39 minus 41 and a half, and so on. So we subtracted here. We got our deviation for every single case. Next step is going to be, based on order of operations, it's going to be square. So here we are squaring negative 0.5, once we square 0.25. Negative 3.5, once we square, we get 12.25, and so on, we square it. After that, we are doing the addition. We add all these numbers. All these numbers that we have, we add them up, we get 88.5. And after that, we divide, the fourth operation is this division. So we divide by n. N was 10, remember, or here it is the same 10. If you count, we have 10. So the result is going to be 88.5 divided by 10. We will get approximately 8.9. Okay, that will be our population variance. Now, population standard deviation, we said it's always equal square root of variance. So square root of 8.85 approximately will give you 3, which means if standard deviation for the hiring salary for the population is $3,000, that means we can say that the given company is hiring from 41,500 plus minus $3,000. So deviation is at error or the spread, how far from average they can go. 41,500 plus minus 3,000. That's the error. Okay. This is about standard deviation and variance. Now, not to go through all this calculation every single time, all you are going to do, open the calculator, which is, I posted in announcement, okay, and you can use it. But for the people who are interested to learn to use all these formulas in Excel, I will record the recording that where I will show you how to find out mode, median, mean, standard deviation, and variance in Excel for the people who are interested in. Okay? So now sample variance. So while we said that for the population, the population variance is sigma squared, for the sample it's going to be S squared. S meaning sample variance squared. So in also here, instead of let me see, instead of mu, here we are using x bar, which is going to be average of the sample. Okay, and instead of n, we have n minus 1 because remember, sample is a subset of population. That means it's at least by 1, it's going to be less. Sample size, elements in the sample are going to be less from population size, at least by 1. Can be more, but at least by 1. Cannot be equal. Okay? Okay. And sample standard deviation, S, square root of S squared. And the entire formula is taken into square root. Now, considering the same problem as in sample size, they are going to calculate everything exactly same way, considering this is sample, exactly same way, with the difference that at the end, so 88.5, instead of dividing by 10, we divide by 10 minus 1 because the formula gives us n minus 1. and we will get 9.8 approximately. Okay, so this is standard deviation and variance for the sample. So sample variance 9.8 and sample standard deviation is 3.1 square root of standard variance. All right. So in this case, they are using here, in this problem, they are using technology to find standard deviation. Whoever is interested, once I show you how to calculate standard deviation in Excel, all you can do, just enter all this data you have, okay, office rental rates you have here, you enter, and you can get the result that they have it right here. The mean is 33.75. Median is this much. Standard deviation is this much. Now, there are several programs that use the statistical calculation analysis. One is Minitab, another one is the scientific calculator, 8384. Well, you don't need to buy because I gave you free online calculator link in announcement. But this is the one I'm going to record real quick so you would know how to calculate all this in your Excel. Whoever is interested can use it. Whoever is not interested, you don't have to use it. What's the advantage of Excel? Because Excel you use in any other business. It's a basic calculation in Excel that will be very beneficial for you at your work. Plus, all your word problems where database is given, it's always right in the left corner, upper left corner, right under the word problem. There is some icon that you click, and that will transfer the given data of your word problem into either the Minitab or StatDisk or Excel. You don't even have to enter the data. You click this icon and then choose the Excel, and all your data will be opened in Excel. So all you have to do, write down the formula in Excel, and it will calculate for you. So I will show that. Now let's look at interpretation of standard deviation. Here is standard deviation is given 0. Standard deviation is given 1.2. Standard deviation is given 3. So the histogram with the greatest standard deviation, which is 0, has the widest spread. Yes? Hold on, let me take red one. Has the most spread here. See? Then here we have less, 1.2, because this is the average, and this is deviation, right? How far they are spread it from average. And this one has 0 because everything in one column. There is no any spread here. We good? Okay. Well, I'm done here with standard deviation. Now moving to empirical rule. What is empirical rule about? So it's the data with symmetric bell-shaped distribution, bell-shaped, right? Use your imagination. It's supposed bell-shaped. It's tell you that if we have a bell-shaped, then 68% of the data, let's say this is 68%, located within average plus minus 1 standard deviation, and that is 68% of data. Next, 95%, let me clean this, I wrote right on the stuff that's going to be 95% of the data is located within 2 standard deviations of the mean. Let me write down here. x bar plus minus 1 standard deviation, that is 68% of all data, x bar plus minus 2 standard deviation, that is 95% of data, and 99.7 is going to be x bar plus minus 3 standard deviation, and we will get 99.7%. So let's use this the result on some example. So here it is, plus this is our x bar, plus minus s plus s, so this is going to be 68%. Actually it should pop up here. Yeah, 68%, and then plus minus 2 standard deviation will be 95%, plus minus 3 standard deviation will be 99.7%. Okay, let's use example to figure out, based on empirical rule, how much is the value that is within 68% or 95% or 99.7% of the database. Okay. In a survey conducted by the National Center for Health Statistics, the sample mean height of women in United States was 64.3 inches. So mean height, so this is going to be x bar, right? Average height. It is 64.3 inches. With the sample standard deviation, because it's a sample standard deviation, we put letter S and it's not sigma. With sample standard deviation is 2.62 inches. Estimate the percent of the women whose heights are between 59%, 59.06 and inches and 64.3 inches. So we need to find the height of women that are between 59.06 and 64.3. Okay, here we have very interesting case. Look here. The high limit of the age for women is sitting right where the average age is, right? Which means we are not going to explore plus S case, but only we are going to explore minus S case. Why? Because our height is going to go from average, right? From average and down below, because our upper limit is 64.3, which is our average. Well, let's check it. So we're going to check exactly the same way I just explained. So, well, I don't like the way they solve this problem. It's absolutely confusing. This is what I'm going to do. Let me scratch this. So this calculation. The graph is good. It can be helpful. But calculation, I don't like it. The way I would solve here, so remember we said x bar plus minus 1 standard deviation is 68%. X bar plus minus 2 standard deviation is 95%. As x bar plus minus 3 standard deviation is 99.7%. So let's check it. Since we have plus and minus, we are not going to check the plus version because upper limit is already sitting on the average, but we are going to check minus version, which means I'm taking 64.3 minus 1 standard deviation, one time, 2.62, right? It's one time. So 64.3 minus 2.62. It's going to be 3 minus 2 is 1. Okay, 14 minus 6 is 8. Here is the decimal notation coming in front. And 5 minus 2 is... Wait a minute. Did I do something wrong? Oh, of course. Hold on. So this is my X bar. So practically what I'm going to do, well, keep jumping. 64.3 minus 2.62, right? Because we are taking 1 times here. So 64.3 minus 2.62, that is equal. So I'm adding 0 because 2 positions here, 2 positions is here. 10 minus 2 is 8. Here is left 2. 12 minus 6 is 6. Decimal notation, point. Here I have left 3. 3 minus 2 is 1. And 6 stays there. 61.68, which is 61.68, which is way above of 59.6, right? All right, checking next one. 64.3 minus twice 2.62. So let's understand. 2 times 262 is gonna be how much? 2 times 2 is 4. 2 times 6 is 12. Here's gonna be a whole decimal. And 2 times 2 is 4, and 1 we had in mind, 5. So 64.3 minus 5.24. That is going to be, so 13 minus 4 is 9. Oh, again 2 decimals, okay. Gee. Oof. Every time it keep running away from me. Just. Okay. So 10 minus 4 is 6. Okay, here will be left 2. 2 minus 2 is 0. Right? 14 minus 5 is 9, and here left 5. Bingo, we get 59.06. And because we got that reaction, that number only because we multiplied 2 times our standard deviation, 2 times standard deviation, that's a 95%. Therefore, we can say that the 95% of women have a height between 59.06 and 64.3. So that is your solution to this problem. If this upper level wouldn't be 64.3, meaning wouldn't be your average, then this one we would calculate also, which means we would do same thing with the plus 2.62 plus twice 2.62 and so on. Okay? So we don't need this because we already solved it. What is left? Just summarize. So we learn the range, variance and standard deviation of the population and sample mean, and we figured out empirical theorem. All right, so we recorded 2.4 also.